NASA's Explorer-1 space probe, the farthest traveling spacecraft ever launched, continues its extraordinary journey through the cosmos, a mission that has now lasted nearly 5 decades. For almost 50 years, Explorer-1 has been sending invaluable data from the most distant reaches of space, significantly advancing our knowledge of the universe. However, recent transmissions from this remarkable spacecraft have revealed astonishing signals that have left the entire space community in a state of awe and confusion. These signals have sparked debates about whether they are the result of a technical glitch or whether they could be indicative of something far more extraordinary, such as extraterrestrial activity. Join us as we delve deeper into the mysteries surrounding these intriguing transmissions and explore what might be lurking in the far corners of space. Humanity's fascination with the unknowns beyond our planet has been a driving force behind space exploration since its very beginning. This insatiable curiosity led to the historic launches of missions such as Explorer-1 and Voyager 2, which were among the most ambitious space undertakings of their time. The launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977, marked the dawn of a new chapter in space exploration. Just 2 weeks later, on September 5th, Voyager 1 followed suit, embarking on an extraordinary mission. These twin spacecraft, each weighing about 720 kilograms, roughly equivalent to the size of a small car, were launched during a rare alignment of the outer planets, which played a pivotal role in their trajectories and mission outcomes. Throughout their remarkable odyssey, these space probes traveled in different directions and at varying speeds. A crucial moment occurred on December 15, 1977, when Voyager 1 surpassed its twin due to differences in their respective paths. Since then, Voyager 1 has become an invaluable resource, providing critical data that has transformed our understanding of the universe and its many phenomena. Before we explore the latest groundbreaking discovery by Voyager 1, which has captured the attention of the global space community, let's take a look back at some of its most significant achievements. In 1978, during its Jovian imaging mission, Voyager 1 was located approximately 265 million kilometers from Earth. By January 1979, it embarked on a remarkable 100-hour mission, capturing a time-lapse video of Jupiter's rotation. This collection of 3,750 images provided unparalleled views of Jupiter's dynamic atmosphere and its intricate features. The probe's findings included the discovery of a small ring around Jupiter and 2 previously unknown moons, significantly expanding our understanding of the gas giant's complex system. To ensure the spacecraft's safe entry and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were performed. Following the success of the Saturn mission, mission specialists decided to conclude the planetary exploration phase for both Voyager 1 and Voyager 2. However, the spacecraft were rerouted on new trajectories beyond the edges of our solar system, traveling at an astonishing speed of 325 million kilometers per year. In January 1990, the interstellar mission officially began, with Voyager 1 continuing its celestial journey. During this phase, Voyager 1 made several notable discoveries, including the identification of 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. The spacecraft also captured some of the most iconic images of our solar system. On February 14, 1990, when Voyager 1 was roughly 6 billion kilometers from the Sun, it embarked on a visual project known as the Family Portrait, which captured stunning images of the inner planets. This series of 60 photographs contributed to Voyager 1's remarkable collection of 670 images taken during its encounter with Neptune. Meanwhile, Voyager 2 achieved impressive feats of its own, including the recording of wind speeds surpassing 13,100 meters per second, the fastest winds ever observed in our solar system. This achievement offered valuable insights into Neptune's distant atmosphere and its largest moon, Triton, whose surface temperature drops to a freezing -391 degrees Fahrenheit, making it one of the coldest places in our solar system. Triton also displayed unique features, including ice volcanoes that erupted nitrogen gas and launched frozen particles up to 5 kilometers into its cloudy atmosphere. These groundbreaking discoveries have greatly enhanced our understanding of the diverse and complex nature of celestial bodies in the outer regions of our solar system. The Voyager missions have produced remarkable results. Voyager 1 and Voyager 2 have revealed that the moons of Jupiter and Saturn, once thought to be inert and lifeless, are actually teeming with geological activity. Voyager 2, in particular, achieved several historical milestones, such as being the first spacecraft to fly past Uranus and Neptune, and it remains the only spacecraft to have done so. NASA used a variety of innovative techniques to extend the operational lifespan of these ambitious missions, including turning off non-essential systems and radiators to conserve energy. The mission is projected to conclude in 2030, marking both a moment of immense pride and a touch of sadness for the scientists and engineers who have dedicated their careers to this extraordinary endeavor. The design of Voyager 1 and Voyager 2 was a feat of engineering. These spacecraft were built as stable platforms, rotating at a rate more than 100 times slower than a clock's hour hand. This design choice minimized visual blurring as the spacecraft crossed the vast regions of space. Even before reaching the outer planets, the spacecraft began transmitting images of Jupiter, revealing its swirling clouds and iconic features, such as the Great Red Spot, a massive storm on Jupiter that has fascinated scientists and the public alike. However, the most captivating discovery was that of active volcanoes on Jupiter's moon Io. The spacecraft's instruments detected unusual signals from Io, which were later confirmed by detailed images showing towering volcanic plumes and a surface scarred by eruptions. One of Io's largest volcanoes erupted with a force 100 times greater than that of Mount St. Helens, covering an area nearly the size of France. As the spacecraft continued their journey, their cameras were eventually turned off to conserve power and memory before they ventured into interstellar space. Notably, the pictures they captured did not include Mercury or Mars due to various factors. In addition to the Voyager probes, NASA has launched other notable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11, becoming the farthest spacecraft from Earth. Despite the absence of other probes to observe it, Voyager 1 continued its solitary voyage for 14 more years before entering interstellar space on August 25, 2012. The progress of the Voyager missions was facilitated by various creative methods, with gravity assist maneuvers standing out as especially brilliant. These maneuvers were essential for propelling the spacecraft toward their distant destinations and collecting valuable data. The spacecraft relied not only on their own propulsion systems but also on the gravitational pull of planets to help them achieve their objectives. Picture two determined spacecraft deftly navigating through our solar system, using the gravitational forces of planets to accelerate themselves. This celestial ballet allowed the probes to conserve fuel and attain the necessary speeds to explore various destinations. Gravity assist maneuvers involve the spacecraft passing close to a planet and harnessing a small amount of the planet's energy to boost its velocity. For instance, as Voyager 1 neared Jupiter, the planet's immense gravity accelerated the spacecraft, increasing its speed. Achieving such precision was crucial. Even a slight deviation in angle or velocity could have led to catastrophic consequences. Despite the complexity of these maneuvers, the brilliant minds behind these missions executed them flawlessly, sending the spacecraft on their extraordinary journey. Voyager 2, for instance, utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune. As we reflect on the extraordinary journey of these spacecraft and the wealth of information they have provided, we eagerly await further developments regarding Voyager 1's recent anomalies. Both Voyager 1 and Voyager 2 continue their missions beyond the natural boundaries of our solar system, contributing invaluable data about Jupiter, its moons, Saturn, its moons, Uranus, and Neptune. Voyager 1's time-lapse images offer detailed views of 10 revolutions of Jupiter, highlighting the discovery of new moons and a small ring around the planet. These findings have significantly enhanced our understanding of Jupiter's complex system. Voyager 1 also identified 4 additional moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and captured surprising images of Saturn and its rings, offering new insights into the planet's intricate system. After completing their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, collecting data about the vast environment. This ongoing investigation continues to expand our understanding of the universe beyond our solar system. As we anticipate further updates about Voyager 1's latest signals and their possible implications for our understanding of the cosmos. The remarkable journey of these spacecraft remains a source of inspiration and curiosity for scientists and space enthusiasts alike. Their groundbreaking achievements continue to push the boundaries of human knowledge and exploration, underscoring the limitless potential of space discovery. The Voyager missions have provided us with a treasure trove of information about our solar system and beyond. Beyond the iconic images and data, the spacecraft have also carried a golden record, a unique artifact designed to communicate the story of our world to extraterrestrials. This golden record contains sounds and images chosen to represent the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and natural sounds such as thunder and whale songs. This message in a bottle reflects the hope that one day, if intelligent life exists elsewhere, they may discover and decode it, offering a glimpse into humanity's essence. Voyager 1 and Voyager 2 were equipped with scientific instruments that have revolutionized our understanding. These instruments included magnetometers, plasma wave detectors, cosmic ray detectors, and imaging systems, each providing vital data about space phenomena. For example, the magnetometers have helped us understand the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the intricate interactions between these planets and their environments. The plasma wave detectors have provided valuable insights into the nature of the solar wind and its interaction with planetary atmospheres and magnetospheres. One of the most significant aspects of the Voyager missions is their ability to measure the heliosphere boundary, a vast bubble of solar particles and magnetic fields that surrounds our solar system. As Voyager 1 approached this boundary, it detected the sudden transition from the solar wind to the interstellar medium. This data has been instrumental in enhancing our understanding of the heliosphere structure and its role in protecting Earth from cosmic radiation. The spacecraft's observations have shown a distinct boundary where the solar wind slows and becomes denser, known as the termination shock. Beyond this lies the heliosheath, a region where the solar wind interacts with the interstellar medium, creating a dynamic and complex environment. Voyager 2's journey has been equally significant. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to send valuable data from the outer reaches of our solar system. Its observations of Uranus were particularly noteworthy, revealing its unusual magnetic field, which is tilted significantly compared to the planet's rotational axis. This discovery challenged existing models of planetary magnetism and prompted further investigations into the magnetic fields of other celestial bodies. In addition to their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The breathtaking images of distant planets and their moons, combined with the personal stories of the spacecraft's journeys, have captured the imagination of people worldwide. The images of Saturn's rings and the detailed views of Jupiter's moons, particularly the volcanic activity on Io, have inspired countless individuals and featured prominently in educational materials, documentaries, and popular media. These incredible accomplishments of the Voyager missions continue to resonate with people everywhere, and their scientific contributions extend far beyond just photographs and data. The spacecraft's findings have helped shape a more complete picture of our solar system and have provided insights into the fundamental workings of space itself. Their discoveries continue to influence ongoing research in astrophysics, planetary science, and space exploration, inspiring new generations of scientists, engineers, and explorers. The data provided by Voyager 1 and Voyager 2 has been instrumental in deepening our understanding of the dynamics of the outer planets and their moons, and the intricate interactions between celestial bodies. The missions have not only offered breathtaking views of distant worlds, but also revealed hidden processes at work in these faraway regions of space. This vast body of knowledge has driven the development of new theories about planetary systems, magnetospheres, and space weather. The work done by the Voyager spacecraft continues to inspire new missions and new technological innovations, propelling us further into the uncharted realms of space. One of the remarkable aspects of the Voyager missions is their longevity. Despite the vast distances the spacecraft have traveled, taking them far beyond the reaches of our solar system, both Voyager 1 and Voyager 2 continue to send back data from the edge of interstellar space. Even though their power sources are gradually depleting and their instruments are becoming less reliable, the spacecraft's ability to continue operating after more than 4 decades is a testament to the foresight and expertise of the engineers who designed them. The spacecraft have far exceeded their expected lifespans, which is a true testament to their engineering, as well as the creative and strategic ways NASA has kept them operational for so long. As both spacecraft continue their missions far from Earth, their legacy becomes more profound. Their work has provided invaluable information not only about the planets and moons of our solar system but also about the environment of space itself, including the mysterious interstellar medium. The data they've gathered has also made us more aware of the challenges we may face in future space exploration, such as the harsh conditions of deep space and the limitations of current technology. The experiences and lessons learned from the Voyager missions will likely guide the design and operation of future spacecraft and space missions. The groundbreaking nature of the Voyager missions is not only marked by their scientific success but also by the cultural and emotional impact they have had. The idea of sending messages out into the universe, in the form of the Golden Record, reflects humanity's desire to reach beyond itself and communicate with possible extraterrestrial civilizations. This act of cosmic diplomacy, of reaching out to the unknown, has captured the imagination of countless individuals, sparking dreams of what might exist beyond our own planet. It highlights the unique position humanity holds in the cosmos, where we have the capacity to send a message to the stars in the hope of connecting with others, even if they exist far beyond our current reach. Beyond just the science and technology, the Voyager missions have contributed to a shared sense of wonder and awe. They have helped remind us of the vastness of the universe and our small place within it, inspiring a sense of humility and reverence for the cosmos. The images and data sent back by the spacecraft have served as a source of inspiration for people around the world, reminding us of our collective curiosity and drive to explore the unknown. The story of the Voyager missions is not just a story of science and engineering. It is a story about the human spirit, our boundless curiosity, and our ongoing search for meaning and connection in the universe. Looking ahead, the legacy of the Voyager missions will continue to influence the future of space exploration. The data they have provided has opened up new areas of inquiry that will shape the direction of future space research and exploration. As we continue to study the data from these spacecraft, scientists will likely uncover even more about the nature of space and the forces that govern it. And while the Voyager missions may eventually come to an end, the knowledge and inspiration they have provided will endure, passing the torch of exploration to the next generation of explorers and dreamers. Moreover, the role of the Voyager spacecraft in promoting international cooperation in space exploration cannot be overlooked. Their success is a testament to the power of collaboration between scientists, engineers, and space agencies around the world. The lessons learned from the Voyager missions have demonstrated how global efforts can unite to achieve extraordinary goals, pushing the boundaries of human exploration and pushing the limits of technology and innovation. The future of space exploration, whether it involves sending humans to Mars, exploring distant exoplanets, or venturing further into interstellar space, will undoubtedly benefit from the foundations laid by the Voyager missions. In conclusion, the Voyager missions are not just an achievement in space exploration. They are a monumental milestone in the history of human understanding. They represent the collective efforts of countless individuals working toward a common goal: to understand our place in the universe and to answer the age-old question of whether we are alone in the cosmos. Through their groundbreaking discoveries, the Voyager spacecraft have provided us with invaluable insights into the workings of our solar system, the nature of distant planets and moons, and the vast, mysterious reaches of space itself. As we continue to study the data they have sent back, we are reminded of the incredible potential for discovery that lies ahead and the boundless curiosity that continues to drive humanity toward the stars. The Voyager spacecraft have redefined what is possible in space exploration. They have shown us that with determination, creativity, and the right tools, we can reach farther than we ever imagined and uncover the hidden secrets of the universe. Their legacy will continue to inspire future generations, and the knowledge they have imparted will form the foundation for many more groundbreaking discoveries. As we eagerly await further updates on Voyager 1's latest anomalies and the future of space exploration, we are reminded of the enduring power of human ingenuity and the infinite possibilities that lie ahead.